Hello friends, today we will learn about string handling in Java. String is a sequence of characters like in other languages, but Java treats them as objects of type string. Unlike C and C++, they are treated as a string object, not a sequence of characters. Because of this, it has all built-in methods to make string handling convenient. Once created, you cannot change the characters that comprise that string. First of all, when we create a string object, that will be treated as a constant, and whatever changes that you are making on that string, that will be done in the copy of string, not the original object. But still you can perform all types of string operations. Every time you change a string, copy of string is modified. The original string is left unchanged. The fixed immutable strings are more convenient than the changeable ones. In Java, that is the advantage of string object. Fixed immutable strings are more convenient than the changeable ones, so that they cannot be modified by everyone who is modifying the program. If you want to change the original string, there is a companion class string buffer. String buffer modifies the original string object. Both string and string buffer class are defined in the same package java.lang, so are available to all automatically. But both are final, you can't create it subclass. So you cannot extend string class and you cannot extend string buffer class, but both extending the java.lang package. Although you can't change strings within object of type string, contents of string can't be changed. You can still point one string variable to point to another string like pointer in C programming. So one variable, string variable, can point to another string. String constructors. String S is equal to new string. This creates string with no characters in it. String characters. This creates strings with initial values. This is the example of string constructor. First is creating a string with no characters. Second is creating string with character array. And third is creating string with sequence of characters. You can specify the subrange of characters array as initializer using the following constructors: string characters, integer start index, integer number of characters. Start index is equal to index where the subrange begins. Number of characters is equal to number of characters to use. So from within that array, if you want to take a subrange, you will specify start index from where you want to take a subrange and number of characters. Like for example, string S is equal to new string characters, comma 2, comma 3. So it will create the characters 2, that is 0, 1, 2. C will be taken, and from C 3 characters will be taken, C, D and E. You can create string that contains same character sequence as another string. So one string object is passed as a second as a parameter to the constructor of second string object, like S1 is equal to new string S. Output of both is same. S is also Java and S1 is also Java. Although character in Java uses 16-bit, the typical for strings and the internet uses arrays of 8-bit constructors from ASCII character set. So standard string object takes the 8-bit bytes constructed from ASCII character. 8 bit bytes are common. String class provides constructor for them also, byte ASCII characters and byte ASCII characters, and subrange of start index from start index to number of bytes. So here ASCII character is basically a character that is given in the ASCII table, and here from 65 to 70 there are they will take the characters that specify this number 65 to 70, and it will display ASCII first of all, and then subrange. ASCII of 65 is A, ASCII value of B is 66. So from 65 it will create A, from 66 it will create B, and so on. And like in the previous example, it takes the characters from C, D and E. Like this, here also it will create a character C, D and E. Extended versions of byte to string constructors are also defined, in which you can specify the character encoding that determines how bytes are converted to characters. Byte to string converter specifies how bytes are converted to characters, but most of the time you will want to use the default encoding provided by the platform. The contents of array are copied whenever you create a string object from an array. So array left unchanged. If you modify the contents of array after you have created the string will be unchanged. So whatever data you are storing in the string object, that will be immutable, unmodifiable string. So when you are creating a string from an array, so it will copy the data of array to the string, and whatever changes you are doing to that array that created that string will leave left unchanged. You can construct a string from a string buffer like this, string object, and you are passing string buffer object. In J2SE5, some constructors are added. The first supports the extended Unicode character set, 4 points, integer start index, integer number of characters. Here code points is an array that contains Unicode code points. The resulting string is constructed from a range that begins start index and runs from a number of characters. It's same way as the previous example. Unicode code points are specified as an integer array, and from start index to number of characters, the subrange is specified. The second new constructor supports the new string builder class. It is shown here. String builder object. This constructs a string from the string builder passed in string builder object. String length. The length of a string is the number of characters that it contains. So length will specify number of characters that it contains. To obtain this value, call the length method shown here. Integer length. The following fragment prints 3 when we are specifying array ABC and length of S is equal to new string of characters S dot length. You can also specify specific string operations. This includes the automatic creation of new string instances from string literals, concatenation of multiple string objects by use of addition operator, concatenation operator, and conversion of other data types to string representation. All done by Java automatically for programmer ease and to add clarity. So concatenation operator basically does what? It concatenates two strings. String literals, those are string constant. String can be initialized using two ways, using character array. First of all, character array is created and that character array is passed to constructor to create a new string. Then you can pass string literal in double quote and you can initialize the string. And because a string object is created for every string literal, you can use a string literal any place. You can use a string object. So instead of string object, you can directly specify string literal, that is constant. Like in the following example, I want to specify length of ABC. So instead of creating new string of ABC like in the previous one, string s2 is equal to ABC, I can directly specify ABC dot length. String concatenation. In general, Java does not allow operators to be applied to string objects. Concatenation is only allowed in string, not other operators are allowed on string. That is, operator overloading is not supported in Java. Why? There is a reason. When we are operator overloading, actually compiler is doing what? Doing the basic operations. Like if you are specifying plus, it is doing addition of two numbers. If you are specifying division, it is dividing one number with another number. And when you are specifying this with the values, like you are modifying that operator with operator overloading. You can you can overload all operators in the previous languages like C and C++. And when you are doing the operator overloading, all the operators the compiler have to check. For example, in your code, you have overloaded plus, minus, multiplication, and division. So compiler gets confused to to which operator it should check for whatever the new changes have done into that. So instead of operator overloading, it is eliminated in the Java. Only concatenation operator using plus operator is allowed. That also on the string objects. If one exception to this rule is a plus operator which concatenates through string, producing a string object as a result. All other operators are not allowed in the string objects. Whenever you are using system.out.println, you can concatenate the string value, string object with the string literal, and so on. And whenever you are specifying the string concatenation operator, if you are specifying the integer value, float value, double value in system.out.println, it will directly convert it to string. You don't have to specify .toString. Like he is age years old. Age is integer. Sorry, here age is 9. But when you are specifying integer age, it will be directly converted to age. One practical use of string concatenation is found when you are creating very long strings. Instead of letting long strings wrap around within your source code, you can break them into smaller pieces using the plus to concatenate them. Public static void main. This could have been a very long line that we would have wrapped around, but string concatenation prevents this. So instead of creating very long line to scroll to the right, we can use string concatenation operator to modify string as a combination of multiple string objects. As I said in previous example, if you are specifying age is as an integer, it will be directly converted to string value. You don't have to specify age.toString. Age is int rather than another string, but the output produced is the same as before. This is because int value is age automatically converted to its string representation within a string object. String is concatenated as before. Compiler will convert operand to its string equivalent whenever the other operand of the plus is an instance of the string. Be careful when you mix the other types of operations. Why? Because this result here 4 plus 2 plus 2. So concatenation does what? As a string concatenation operator has the highest priority, it will display 2 and appended by 2. So 2 integer is converted to toString and displayed, and other second integer is converted to string and then displayed, rather than 4. So to provide the operator precedence, you have to specify the braces. Like when you are specifying the brackets, those are given the highest priority as in the priority chart, and 2 plus 2, that is 4, is done first, and from right to left all the values are converted to string. 4 is converted to string and then appended with the 4. String conversion and toString methods. When Java converts data into its string representation during concatenation, it does so by use of one of the overloaded versions of the string conversion method, value of method defined by strings. Value of is overloaded for all simple types and the for type object. For the simple types, value of returns a string that contains human readable equivalent of the value with which it is called. For objects, value of called the toString method on an object. On the object. So here is an example toString method, because it is the means by which you can determine string representation for objects of classes that you create. Every class implements toString. Default implementation of toString is seldom sufficient. For most important classes, you will want to override two strings and provide your own string representation. And this is easy to do using .toString method. Simply return a string object that contains the human readable string that appropriately describes an object of type class. So using toString is very simple. Just give the object name and .toString. By overriding string for classes that you create, you allow them to fully integrated into Java's programming environment. They can be used in print and println and in the concatenation expression. The following box example demonstrates this by overriding toString for the box class. Double width, double height and double depth, as we have seen in the previous examples, the same box class is used. So width, height and depth are double. We are initializing them, and what we are doing in the toString method, we are overriding this, and dimensions are width, depth and height. So actual toString only convert the value to string representation, and this toString is doing what? It is giving the complete string, like dimensions are width by depth by height. Here is one more example. Public static void main box b is equal to new box 10, 12 and 14. Then box b plus b. So b is what? Object of type box. And when you are providing the b as a system.out.println, convert box to string system.out.println. So here what we did, we initialized it in a parameterized constructor, then we overridden the string method, toString method, and then we printed this b into system.out.println. So 10, 12 and 14 values are displayed inside the output. Box toString method is automatically invoked when box object is used in concatenation expression or call to println, here and here. Dimensions are here also and box b here also. Character extraction. We can extract the particular character from the string representation. The string class provides a number of ways with which characters can be extracted from a string object. Although the characters that comprise a string within a string object cannot be indexed as if they were character array, you can still use the index of. The string methods employ index or offset into string for their operation. Character at method is doing so. The index starts with 0. To extract a single character from a string, you can refer directly to an individual character via character at method, like in following example what we are doing, abc dot character at 1. So 1 will return b to ch. Get characters. In get characters, it will give the characters from the string. Here character at will specify a single character at that particular location, and get characters will provide the group of characters. So what is the syntax of get characters? Void get chars, integer source start, integer source end, character target, integer target start. Here source start specifies the index of the beginning of the substring, and source end specify the index that is one past the end of the desired substring. So what is the source? We are specifying the source at the left of the get characters method. Then from where to start, it's given in the first parameter. Then where to end plus 1 is given in the second parameter, and target at what array, which array you have to store the output, and target start, from which location you want to store the output. It may happen like you have array given, like hello is already there in target array, and you have to append it word. So source is having your character array word. So you have to append hello with world. So in that case, after hello, 5 at 6 index. So index target start will be 6. From 6 you will write word in the target array. This is a demo of get characters method. Integer start is 10 and end is 14. So character buffer array is done for end minus start. So for 4 values, new array is created for storing 4 characters. 14 minus 10 is equal to 4. From start 10 to end 14, you have to store it in buffer. What is the value? From 0. So demo is a letter that is at index 10 in the string s, and we are extracting that demo from string s and we are storing it into buffer array and we are printing the array buffer. What is it? Demo. Get bytes. Alternative to get characters is that get bytes, that stores the characters in an array of bytes. This method is called get bytes and it uses the default character 2-byte conversion. Simplest form byte get bytes. Default character to byte conversion provided by the platform. Other forms of get bytes are also available. Get bytes is most useful when you are exporting a string value into an environment that does not support 16-bit Unicode characters. When your environment is not supporting 16-bit Unicode characters, get byte is written a single byte, that is a 8-bit. Most internet protocol and text file format use 8-bit ASCII for all text interchange. Here, get bytes is useful when it returns with 8-bit Unicode characters. Then 2-character array. Convert the string object to character array is very simple because the convenient method is provided, 2-character array. If you want to convert all the characters into string object to character array, use the 2-character array method. It will return the character array. String comparison. There are 2 methods for this. It available equals and equals ignore case. To compare 2 strings for equality, use equals. Like if one string elements and other string elements are same, equals is useful. Here string is a string object being compared with the invoking string object. It returns true if the strings contain the same characters in the same order and false otherwise. Same set of elements, same set of characters in the same order and false otherwise. And actually capital case and small case you want to check with the order of characters and number of characters and the characters, you can use equals ignore case. When it compares to string, it considers A to Z to be same as A to Z. Equals ignore case. Here is a simple example of equals and equals ignore case. String S2 is equal to hello, string S3 is equal to goodbye, S4 is equal to hello. So first of all, what we are comparing? If S1 equals to S2. So hello and hello, same to same. So it will return true. Second is S1 equals S3. Hello is goodbye, no. Same set of characters are not available, so it will return false. Third one we are checking S1 equals S4. It will also return false. Why? Because number of letters, then sequence of letters and also letters same, but capital and small is not same. So it will return false. And in the last case we are using equals ignore case. So capital and small is avoided, only the sequence of letters is checked. Here is also HELLO and here also HELLO. So in that case it will return true. So equals ignore case does what? It will treat A to Z capital as a to Z small. So number of characters and sequence of characters are same. In that case, equal ignore case will return true irrespective of case of letter, capital or small. Region matches. This method compares a specific region inside a string with another specific region in another string. For example, there is an overloaded form that allows you to ignore case in such comparison. First one is Boolean region matches start index integer string to integer start to index and number of characters. So specific string, specific region inside a string with another specific region in another string, it will compare. The second format is Boolean ignore case start index string to integer start index integer number of characters. The string being compared is specified by string 2. So the string you are comparing with will be at the left side of dot operator. Then from which position you want to start, it will be provided in the start index. After that, which string you are comparing with will be given in string 2, and from which index to number of characters you want to check the region, it will be checked with number of characters. It will be checked with start index and number of characters. The string being compared is specified by string 2. The second version, if ignore case is true, the case of characters is ignored. Otherwise, case is significant. Starts with and ends with. String defines two routines that are more or less specialized forms of region matches. If that particular string is starting with this or ending with this. Start with method determines whether a given string begins with a specified string. Conversely, ends with determines whether the string is question, ends with a specified string. Boolean starts with string and Boolean ends with string. Here string is the string be tested. If the string matches, true is written, otherwise false is written. Foo bar ends with bar, true, because bar is there at the end of foo bar. Foo bar starts with foo, yes, both are true. The second form of starts with, as shown here, it's to specify the starting point. Boolean starts with string integer start index. Here start index specifies the index into the invoking string at which point the search will begin. If you are using starts with bar and index is 3. So at index is 3 onwards, bar is starting, bar is there, yes. At position 3, B is there. At position 4, A is there. And position 5, R is there. So from 3 and onwards up to the end of string, there is a bar available. So it will return true. Equals and double equal to. It is important to understand the equals and double equal to operator perform two different operations. As just explained, equals method compares the characters inside the string object. Equal to operator compares two object references to see whether they refer to same instance. So exactly same strings are given checked inside the equals method, and is equal to compares two object references to see whether they refer to the same instance. The following program shows how two different string objects can contain the same characters, but references to these objects will not compare as equal. First string is hello, second string is given the reference of first string. S1 equals S2. Hello equals hello is equal to true. Why? Because equals check the exact equality. And hello is equal to hello. Hello is referring S1 equals hello. S1 is hello first object, and S2 is hello second object. So though both referring to same object, no, they are different objects. And S1 is equal to S2. S1 is equal to S2. Here is printed. The variable s1 refers to the string instance created by hello. The object referred to by s2 is created with s1 as an initializer. Thus, the contents of the two strings objects are identical, that is hello, but they are distinct objects. This means s1 and s2 don't refer to same objects and are therefore not is equal to, as shown here by the output of preceding example. Then compare to. It is not enough to simply know whether two strings are identical. For sorting applications, you need to know which is less than, equal to, or greater than the next. String is less than another if it comes before the other in dictionary order. String is greater than another if it comes after the other in dictionary order. So comparing two strings is made very easy with this function. So this is very important function to learn. Compare to. If one string is less than another, that means that in the dictionary first string comes before than the second string, and if string is greater than another if it comes after the other in the dictionary order. String method compare to serve this purpose. Integer compare to string. Less than 0, the invoking string is less than string. Greater than 0, the invoking string is greater than string. And 0 means the two strings are identical or equal. Here is an example. Now is the time for all good men to come to the aid of their country. So, from 0 to array of length, it will iterate from integer ij plus 1 less than array of length I plus plus. Okay. So, j will start from now and I will start with s, is. So, for every particular string in the string array, what it will do? It will take the string. Then it will compare that string with all the other strings. And it will sort the string in the dictionary order. If array of I compared to array of j is less than 0, that means if is less than now, so is will come first and string of t, temporary string, is taken array of j. So array of j is what here? Now. So now will taken outside, then is taken in the array of j, that is at place of now, and at array of I is equal to, array of j is equal to t. Then temporary variable now is replaced with the second position, and then sorted array is displayed. So first one, you have to know that now still comes before the small letters in the Java ASCII table. So before add is come now, so now is not considered because all the capital letters come before then the small letters. Because it begins with uppercase letter, which means it has a lower value in ASCII character set. Integer compared to ignore case. If you want to ignore case differences when comparing two strings, then you can use compare to ignore case. Here case differences are not taken into consideration, so you can use the compare to ignore case, and then now will be no longer the first, because here n will be considered same, capital N will be considered same as a small s, small n. Then searching string. String class provides two methods that allow you to search string for a specified character or substring. Index of and last index of. Index of searches for the first occurrence of characters or substring, and last index searches for the last occurrence of the character in a substring. These two methods are overloaded in all different ways. All cases the methods return the index at which the characters or substring was found, or 1 on failure. If it is returning 1, that means failure is occurred, and if it is not returning 1, it will return the index at which character or substring was found. Integer index of integer character. It will search for the first occurrence of the character. To search for the last occurrence of character, use last index of. Here ch is a character being sought. To search for the first and last occurrence of substring, use index of and last index of. Here it will search for a substring, not a single string. Here string specifies the substring. You can also specify starting point for the search using these forms. Then integer index of integer character, integer start index. So from specify the starting point, specify the character and starting point for the search using these forms. From where you have to search. And last index of, here also you can specify from where you have to search. Then index of and last index of substring. String and start index, string and start index. Index of search runs from the start index to the end of string, and last index search runs from start index to 0. Now is time for all good men to come to the aid of their country. Here index of and last index of is used. This is the output of the program. We will take the simple example of first one, index of t. So first occurrence of t is counted and displayed. First index is 7. Likewise, last index and all the indexes are found and displayed over here. Then modify string. First one is if you want to modify string, use the substring method. You can extract the substring using substring. It has two forms. First is string substring integer start index. Here start index specifies the index at which substring will begin. This form returns a copy of the substring that begins at start index and runs to the end of the invoking string. The second form of substring allows you to specify both the beginning and ending index of the substring. String substring integer start index, integer end index. Here start index specifies the beginning index and end index specifies the stopping point. From start index to end index, substring will be found. The string return contains all the characters from beginning index to but not including the ending index. Here is the example. This is the test, this is 2. So replace all the matching substring. First of all, what we are doing, displaying the main string. This is the test, this is 2. I is equal to index of search. What is the search string? Is. So what is the occurrence of is in the first occurrence of is in the org? 1 2 3 4 5 6 6. Okay, so if 6 is not equal to -1, means there is a present is present inside the string. Then what we are doing, org dot substring 0 of I. So 0 to I, that is this. We are taking this outside, then result is equal to result plus sub. This was, so sub is was, so this and was are concatenated, then result plus org plus substring I plus search dot length. So search dot length value is added with I index, and then output substring is concatenated with result, and then result is displayed. First of all, this is test, this is 2, this was the test. So first occurrence of is replaced with was, like this. Then second occurrence of is replaced with was. Then third occurrence of is replaced with was, and fourth occurrence of is also here also replaced with was. Here this is here is replaced with was. This is replaced with was. Then this is replaced with was, this is replaced with was, then this is replaced with was, and this last is replaced with was. And concat, you can concatenate using the concat method instead of plus operator. S1 concat 2, it will return 1 and 2. Replace method has two forms. First, replaces all occurrences of one character in the invoking string with another character. Character original, character replacement. Original specifies the character to be replaced with the character by replacement. Hello replace L and W. The second form of replace replaces one character sequence with another. Replace character sequence with another character sequence. Trim method returns a copy of invoking string from which any leading and trailing white spaces has been removed. So when you are trimming it, unnecessary white spaces are removed. When you use process user commands, it is very useful. For example, the following program prompts the user for the name of state and then display the state's capital. It uses trim to remove any leading or trailing white spaces that may have inadvertently been entered by the user. Buffer reader object is created. Buffer reader here is equal to new buffer reader, then string str, then enter stop to quit, enter state. Okay, so buffer read line will read the state. Then remove white spaces is done by using string. If string equals Illinois, capital is Springfield. String equals Missouri, capital is Jefferson City. If string equals California, capital is Sacramento. If string equals Washington, capital is Olympia. This way, all the trim is occurred. Data conversion using value of. So, value of particular double long object and characters can be converted to string representation. It is a static method that is overloaded with the string for all Java's built-in types so that each type can be converted to properly or to a string. As we discussed earlier, value of is called when a string representation of some other type is needed, for example, during concatenation operator. We can use this method directly with any data type and get reasonable string representation which is already specified. All methods are built in, so you don't need to do any conversion by your own. All of the simplest types are converted to their common string representation. Any object that you pass to value of will return the result of object's toString method. It will return the string representation. So toString and value of will give the same result. For most arrays, value of returns the rather cryptic string, which indicates that it is an array of some type. For arrays of character, however, string object is created that contains the character in the character array. Special version of value of is static string value of characters, start index and number of characters. Character is the array that holds characters, start index from which to value of returning to a desired substring begins, and number of characters specify the length of the substring. Changing the case of characters to lowercase and to uppercase, you can change the letters in the characters. Here, this is a test is done in capital with using to uppercase method and done in small in to lowercase method. Additional string methods, there are summarized in the following table. So there are some different types of methods available. Code point at returns the Unicode code point at the location specified by I. All these methods are added by J2SE5. Integer code point before returns the Unicode code point at the location that preceded that specified by I. Code point count, start and end, returns the number of code points in the portion of invoking string that are between start and end. -1. Contains, returns true if the invoking object contains the string specified by the string, returns false otherwise. Content equals character sequence string, returns true if the invoking string contains the same string as string, exactly equal. otherwise return false. Content equals string buffer string if the string object the same string as string buffer object. String format returns a string formatted as specified by formatted string added by receive 5. String format. Then local object string from string object arguments. Returns a string formatted as specified by formatted string. Formatting is governed by the local specified by local. So which local you are using? Like you are using the Hindi language, Marathi language, Nepali language, Tamil language, and so on. Boolean matches string region expression. Matches is already done. Returns true if the invoking string matches the regular expression. Expression passed in regular expression. If invoking string is matching the regular expression, otherwise return false. Offset by code points. Start and integer number of characters. Returns the index with the invoking string, that is number code points beyond the starting index specified by start. String replace first string regular expression string new string. Returns a string in which the first substring that matches the regular expression specified by regular expression is replaced by new string. Returns a string in which the first substring that matches the regular expression specified by regular expression is replaced by new string. Replace all returns a string in which all substrings that match the regular expression specified by regular expression are replaced by new string. All occurrences, all substring that match the regular expression given in the parameter first string regular expression is replaced by new string. Then split method decomposes the invoking string into parts and returns an array that contains the result. Each part is delimited by the regular expression passed in the regular expression. Then split, it returns the array, decomposes the invoking string into parts and returns an array that contains the result. Each part is delimited by the regular expression passed in regular expression. Then the number of pieces is specified by max. If max is negative, then the invoking string is fully decomposed. Otherwise, max contains a non-zero value. The last entry in the return array contains the remainder of the invoking string. If the max is 0, the invoking string is fully decomposed. The character sequence, subsequence, integer start index, integer stop index. Returns a substring of the invoking string beginning at start index and stopping at stop index. This method is required by the character sequence interface, which is now implemented by the string. So this way we have finished the string handling theory part. In the next session, we will see practical part of string handling, that is actual implementation, how string objects are created and modified. So meet you in the next session. Thank you so much.